And then we have seen that there is one round function. In round function, you are having multiple things, and you are having permutations, initial permutations, as boxes, key boxes, expansion boxes. But what about key? So that was the question, that what happens to the key which you are giving. So initially I told you that the key bits, whatever is given to the algorithm, is 64 bit. But from this 64 bit, here this is the whole key generation diagram of your key matrix. So in key, exactly what is happening, that when you're providing the key and the key is of 64 bit, then this 64 bit key is given to parity drop. Parity drop signifies that which are parity bit, the last bit is always considered as a parity bit. So 8th bit, 16th bit, 24th bit, 32 bit. So this is the parity bit of this 64 input key bits. So from that, the parity bits are totally dropped. So first of all, 64 bits are given to parity drop, which will convert 64 into 56 bit. So this is the reason why the key length of my DES cipher is 56 bit. So instead of 64 bit, always it is considered as 56 bit, because the major core bits which are considered in case of DES algorithm is 56 bits only. If 64-bit input is given, then it is parity drop. Parity drop means parity bits are dropped. And because of that, it is converting 64-bit into 56-bit. Because from 8 blocks, 64 means 8 into 8. So 8 blocks are there. From all these 8 blocks, the last bit is taken out. So you are having 8 into 7. So because of that, 8 bits are converted into 7, and you are having such 8 blocks. So 8 into 7, so 56 bit are the core bits which are given to the key generation algorithm or key generation matrix for DES algorithm. Now, what is the purpose of this key generation? Now, as I told you that confusion and diffusion, these two properties were there. Diffusion says that the confusion says that the relationship between the key and that of ciphertext should be as complex as possible. When we are creating the complexity, we are increasing the complexity. At that time, what will happen? That number of cipher key beats have to be impacted on number of key cipher text beat. So key beats are to be affecting multiple cipher text beats. So this is the relationship, that not a single or not two, not three, but arbitrarily some bunch of beats from key has to affect the ciphertext beat. So because of that, this 56 beat is somehow converted into 48 beats. Now how it is converted? So first thing is that as you know that the whole modern ciphers, the whole principle works on Feastal cipher structure. So Feastal cipher structure says that if you're working on a block which is of huge length, then it will take a huge time, or it will take more time in case of computation. So instead of that, if this algorithm is implemented in hardware, and the number of bits or number of bytes which are given to the hardware, once it is running parallelly, you will get the computation power high, or you can compute it fast. So because of that, always in case of plain text also, it was divided into 32-bit, 32-bit. In case of key also, it is divided into 28-bit, 28-bit. So left 28-bit and right 28-bit. So after that, you are having shifting. Now, this is considered as this 28 beats, whatever 28 beats we are getting from direct key. So, because for the first round, the sub key generation will give you the key, the round key, and that round key should be converted from 56 to 48 beats. Now, for that reason, you are having shifting. So, left shift you have to do, but how many left shift has to be done? So, depending on round number, so on which round I'm concentrating on, you're having different shifting. So if it is round number 1, 2, 9, 16, number of left shift is 1 beat. So 1 beat left shifting is done in round number 1, 2, 9, 16. And in all the other rounds, we have to do 2 beats. So 2 beats means left shifting has to be done, but twice. So 2 times we have to do left shifting in case of key generation for rounds number which are apart from 1 to 9 and 16. So if it is round number 1, then left shift on this 28 beats, left shift on this 28 beats, the leftmost and rightmost 28 beat is ones. Now what this compression P box is doing, so compression P box is, so what is the input 28 beat and 28 beat. So when you're merging this together, again it is considered as jumbling, it is considered as permutation of all the beats, because original 28 56 beat is after shifting, you will have another combination of 56 beat. Now once this 56 bit combination is given as input to the compression P box, now what this compression P box will do, that it is converting 56 bit into 48 bits. Now 56 to 48 bit compression is done by compression P box, because this 48 bits are taken for XORing with 48 bits when you are doing the expansion. From 32 to 48, whatever expansion P box, what we have seen in case of plain text in round of function. So this round of function XORing is done with this 48 bits. So compression P box is, by the name compression is given, because from 58, from 56, you are converting that thing into 48. So compression P box is converting 56 into 48, and that is nothing but your round key function. Now this round key function is giving 48 to round number 1. But when you are concentrating on round number 2, because how many such type of keys are to be produced by key generation? So key generation will produce as many number of rounds are there. So from DA's point of view, you are having 16 rounds. So 16 such type of keys, and these keys are considered as sub key. Subkey generation algorithm. So subkey of 48 bit is converted from this to this. Now compression P box is arbitrarily dropping 8 beats, because once you are converting 56 to 48 bit, 8 beats are to be totally ignored. In case of parity drop, it is firm that only the last beat, beat number 8, 16, 24, 32, this type of last beats are dropped. But in case of compression P box, arbitrarily any character or any beat can be compressed. Compressed means it is ignored. And likewise, 8 beats are taken out and you are having a matrix, and this matrix is taking input as 56 bit and giving output as 48 bit. So subkey generation, that is giving you 48 bit, and this 48 bit is given further for further evaluation. Likewise, shifting. So now here no swapper is there. Keep this thing in mind. In case of plain text, in case of round of function, we have seen that you are having mixture swapper. This type of rounds are there. Mixture, which is doing what? Expansion, substitution, expansion, substitution. Lastly, the leftmost bit and rightmost bit are interchanged. So this is mixture swapper. Mixture swapper type of combination is there in plain text when you're converting plain to cipher. But when you are generating the subkey, at that time, directly dropping the beat for the first time, you are dropping the parity bit and then divided into two half, the leftmost 28 bit, rightmost 28 bit. Then you are doing shifting, left shifting. How many times left shifting? Depending on the round number. 1 to 9, 16, and the other 1 bit and 2 bit, that is concentrated on or that is considered. And then you are having compression P box. Compression P box will convert 56 into 48. So likewise, this leftmost bit, which are nothing but shifting by 1 bit for round number 1, that is given to the second round. In case of second round, how many shiftings are there? So if it is round number 1 and 2, again number of left shift is 1 only. So you can see over here the round number as well as how many times the shifting has to be done. So both the things are mapped together, both the things are specified over here. So after that, in the case of round number 2, after you have done the left shifting, again the same process. Because here the criteria is what? Something which is repeated for multiple time, it creates complexity, it increases the complexity of the algorithm, because from the attacker point of view, he won't be able to get the plain text from the cipher text. So the same criteria is applied. Shifting, left shift, depending on number of round, compression P box, and then again what you are generating is 56 to 48 bit mapping. Compression P box is doing 56 to 48 bit mapping. What you are getting is 48 bit. So that is your round key 2. So from round key 1, 48 bit, this is your sub key 1. For round number 1, sub key 2, likewise, you will get sub key 16. So 48 bit input you are getting like this. So it is halving the key into two parts, shifting and then compression. Same criteria is applied for 16 time, and then what you are getting is the round key or the sub key function. The sub key which is given to the XORing function of the plain text. So am I clear to you? So this is very easy for you to understand that what exactly it means. That parity drop. So parity drop you can see over here. Key number, beat number 1 is there, 2 is there, 3 is there, 4 is there. What is missing? 5 is there, 6 is there, 7 is there. Within the whole parity drop table, you won't get beat number 8. Likewise, beat number. So these beats are totally dropped, and internally all these beats are placed arbitrarily over some position. So even there is some criteria which is used over here, 1, 2, 3, then 4 over here, 5 over here. So this signifies that this says that beat number 1 has to be placed where? So it should be placed at position number 8. Beat number 2 has to be placed on position number 16. Likewise, this is the output, because this is nothing but from 64 you are converting that thing into 56. So from 64 bit you are converting that thing into 56 bit, and these are the exact 64 bits from that which beats are converted into 56 beat. So beat number 1 is used, 2 is used, but place at what position? So at those position numbers are given. So am I clear to you that these are nothing but position number, that original 64 beat, from that which bit is taken and placed over which position. So this is nothing but your parity drop table. Likewise, here it is given that round number 1, how many shifting has to be done? So left shift has to be done, but how many times? Left shifting for round number 1, it has to be done for one time. Round number 2, it has to be done for one time. 3, it has to be done for two times. So if you are doing left shifting, but again, just from computation point of view, it is restricted either one or two. One or two. Are you getting that? So you are not considering 3 times, 4 times, 5 times, 1 or 2, because both the things are to be balanced. The computation power should be less, as well as the security of the algorithm should be sustained. So both the criteria are to be considered together. So because of that, in designing the algorithm, this type of criteria is used. And here comes the compression table. So compression table, when it is used, when you are converting 56 bit into 48 bit, at that time, this is the compression table. So in compression table, you won't have a specific thing that beat number 8 is there, beat number 16 is there, beat number this is there. So it is not that only parity beats are dropped. Arbitrarily, any beat can be dropped. So those beats, those 8 beats are discarded, and it is not in a sequence. That what type of sequence is used is not fixed. So because of that, it is converting 56 beat into 48 beat, and some of the beats are discarded. So this is nothing but compression table converting 56 beat, 48 beat, 56 beat into 48 beats. Now this is the algorithm. So again, algorithm, what we have seen in case of pseudocode, what we have seen in case of plain text conversion, that you're having round up function, you're having mixture function, you're having swapper function. So in case of algorithm for key round key generation, the sub key generation matrix, the sub key generator, what you're having, you are having 64 bit, which is the input to the algorithm. Then you are having the round keys, 16 or 48 beats. So these are 16 rounds are there, and key what has to be generated is of 48 beat. So these are nothing but beat. How many beats are more important than shift tables? So how many shift tables are there? 16, because 16 number of rounds are there, and you are having 16 type of tables. Shift table is this. This is your shift table. Are you getting that? Round number 1, how many shift? 2, how many shift? So these are specified in your shift table. And the input, the key which is of 64 bit, it is given. From 64 bit, the first thing is parity drop. So within the algorithm, the first thing is permutation. So permutation, whether you are doing some substitution from one bit to the second bit, one is not converted into second into zero, or zero is not converted into one. All the beats are as it is, but the positions are changed. So because of that, first thing what you have to do is permutation. Permute the position, internal position of all the beats, and that is done by parity drop table. So parity drop table is converting 64 bit into 56 bit, and here the most important part is only parity beats are dropped. Then you are having split. Split signifies that 56 bit is there, it has to be converted into two equal halves. So these two equal halves are nothing but 28 bit, 28 bit left key and right key. Now, when you are having left key and right key, after that, for how many rounds are there? There are 16 rounds. So this criteria has to be repeated for 16 rounds. So shift left on left key, shift left on the round key, and you should have with you the shift table. So this shift table will be useful to you that if it is round number 1, shift left for one time, shift left for one time if it is a right for one time, left for one time on the right key if the round number is 1, is 2. But if the round number is 3, then you have to do left shifting for 2 times. So because of that, this shift table must be there with you. Once shifting is done on 28 bit, both 28 bits are combined together. What we're getting is 56 bit. So you are combining together 28 bit left and 28 bit right, and the resultant answer what we're getting is left key and right key, and this is nothing but pre-round key. Pre-round key. Now this is not the answer. 56 is not the answer what is expected, because again from 56 you have to convert that thing into 48, and that is done by compression table, key compression table. So are you getting this? So 56 has to be converted into 48 bit pre-round keys input to the algorithm. The round key, this is the output of the algorithm, which is of 48 bit, and what we have to use is key compression table. Again, I'm telling you that DS algorithm you have to implement. After your midsem exam is over, I provide you the deadline by which you have to complete this DS. So in completion of this, it is again I'm telling you, it is not so hard to implement, because the important part is all the tables. Once all the tables are there with you, it is very easy to plug the input and then you will directly get the output because only tables are there. So what you are having is the compression table, and this compression table will convert 56 bit into 48 bit, and the resultant answer is round keys. Now these are the round keys. Such type of 16 round keys you will get. Depending on different number of rounds, you will have such round keys. Now this is the way that how you are doing the shifting. So left shifting, right shifting, number of rounds, how many numbers of shiftings has to be done. So this is even easy for you that how you are doing the shifting. Now here one example is given to you, and what I'm expecting from you people is do this thing yourself on pen and paper. Take a pen and a paper and then try to get answers which are specified over here. So first thing, what do people have to do? What do people have to do is this, that we choose a random plain text block and a random key and determine what is the ciphertext block and what is given over here, say 1, 2, 3, 4 ABC, this is in hexadecimal. So input plain text is of 64 bit and characters what are taken over here. So they are specified over here. So this is in hexadecimal. This is convert hexadecimal into corresponding binary. The first thing what people have to do is convert, because the whole DS algorithm is working on binary beats. So binary beats is expected from DS point of view. If your plain text and the key is in hexadecimal or decimal or in other uh, form, then simply convert that thing into binary beats. So beat form, you have to convert that thing. So 64 beat input plain text and 64 beat input key. These two things are needed as input to the algorithm. So what will happen, that the plain text, what you're having, 1, 2, 3, 4, 5, whatever is given to you. First of all, you have to perform the initial permutation on that. So initial permutation, initially I told you that what was initial permutation? Again, this 64 beats are jumbled together, and for that a direct table is available. In initial permutation, we have seen that you are having a direct table. So only this direct table has to get, this is the initial permutation. Beat number 56 of my original plain text has to be placed as the first beat, which is considered as output of initial permutation. Are you getting this? Likewise, beat number 50 has to be placed over here. So one thing what you have to do, that you are having 64 beat, give numbering to each and every beat. So if I'm writing an algorithm, it would be very easy for me because I'm having index. Indices are very important. So index number 57 I have to place over here, because from array point of view I have 0, 1, 2, 3, 4, 5. So index number 0. index number 1, index number 2. So beat number 58 is nothing but value at index number 57. So directly you can place over here. Likewise 49 you can place over here. 51 if it is index. Are you getting? If it is considered as an array, something like this mapping would be there. From the positional plain text you will have the corresponding initial permutations. So that was the first step, that when you are writing an algorithm, or when you have to write, when you want to solve an example of BS type, the first thing what you people have to do is convert plain text into binary. On the binary, perform the initial permutation. After initial permutation, you will have 32-bit L0, R0. L0 is nothing but 32-bit leftmost characters and 32-bit rightmost bits. So rightmost characters means 1, 2, 3, 4, 8 I have to take because it is in hexadecimal. In hexadecimal, 8 I have to take, and here from this also I have to take 8. So what I'll get is L0 and R0. So it is leftmost 32-bit and rightmost 32-bit. So are you getting this? So this is the algorithm. What is expected, that L0, R0 you are getting after initial permutation. Again, I just want to remind you that from your MCQ point of view, also I'll ask you that the output of the you can say expansion P box. Expansion P box is used for converting 64 to 56. Whether it is true, expansion P box is used for converting 64 to 56. So you should know that what are the names of all this. Initial permutation is converting 64-bit into 56-bit. Is it true? No. Initial permutation is converting 64 into 64 only. So it is simply rearranging the position of all the bits. So this is something what I want to say. Likewise, round 1, round 2, round 3. So leftmost bit which is given to round 1, rightmost bit which is given to round 1 is this. The subkey generation, that is this. So this key is used, this plaintext is used. Initial permutation, you are having L0, R0. After that you will have L1, R1, and likewise all the values are specified over here. So check it from yourself when you are writing the algorithm, when you are understanding the algorithm, and everything is there with you, you will be able to get the answer like this. So once the answer is there, you can combine both this thing, and this becomes your cipher text. So this becomes your cipher text. So C0F B7. So after final permutation, what you are getting is the corresponding ciphertext. So lastly, whatever output of round number 16 has not to be considered, but after final permutation, here you can see over here that after round number 16, there is no swapper function. You don't have to swap the values of L0 and R0 or leftmost and rightmost 32-bit, but instead of that, it is directly given to final permutation. And final permutation, after applying the final permutation, whatever you are getting, that is nothing but your cipher text. So this is the example of cipher text what you are getting over here. So here the same thing is given to you, that if your ciphertext is this, when you are doing the decryption at that time, what type of criteria you will get? When you are getting the decryption after final permutation, you will get the original plain text back. So just for your reference, this example is given to you. Take a pen and a paper, understand DS properly. Once all the tables, permutation tables, expansion tables, substitution matrices, and everything is there with you, you can solve this example easily. So that is DES, the end of DES. That one example, you can solve it yourself, and all the tables must be there with you. So as far as DS is concerned, can you say that DS is considered as a robust algorithm, or you can't break the cipher which is DS? Now, initially it was considered that yes, DS is a robust cipher till some drawbacks are found within the algorithm. So once those drawbacks are found, always the necessity of a more secure algorithm is there. Because of that, in DSA, it was discovered that as the computation power increases, as the hardware capacity increases, even DS is breakable. Breakable within some number of days, within some number of hours, given some prerequisite conditions. So because of that, the new algorithm what we people are going to learn, which is the advanced version of DS, is triple DS AES advanced encryption standard. So that was increasing the plaintext length, increasing the key length, what you are getting is more robust algorithm than that of DES. So here some examples are given to you, and there is one effect which is avalanche effect. So avalanche effect says that if plain text is of this type and key or is of this type, the key is of this type, what you are getting is ciphertext as this. Likewise, avalanche effect, what is the meaning of this avalanche effect? See this, that I am using plain text which is all 0, I am using a plain text which is only 1. So if the same key is applied on this plain text and the algorithm which is used in DES, then too you can see the difference between the ciphertext. Now ciphertext, when we are generating for plain text 0, everything 0, and plain text everything 0 except 1, the last one, the difference between the ciphertext of both this plain text is huge. So this is considered as avalanche effect. This is considered as avalanche effect, that a single beat change within the plain text should affect number of ciphertext beat, or the analysis should not be possible to have a one-to-one corresponding between the plain text and ciphertext. So DES is having a strong avalanche effect. Avalanche effect says that a single bit change within the plain text will affect multiple ciphertext beat. And if it is observed that it is affecting multiple ciphertext beat, then it is considered as DES is quite robust, because avalanche effect is produced within DES, and that is one of the criteria which is needed in modern block cipher. So this is the case which is given over here. Even some examples are there. That completeness, what is the meaning of completeness? So completeness effect means that each bit of ciphertext needs to depend on multiple bits of plain text. Each bit of ciphertext depends on multiple plain text beat, and again it can be considered as diffusion. Multiple plain text beat diffused within a single beat of ciphertext. So diffusion property, completeness property should be there, is incorporated into DES to make it more robust. So that was the criteria. How many, say this we have seen in previous lecture, that how many S boxes, how many P boxes, or what should be considered in case. So double DES, triple DES, we will see in next lecture. So I am ending this lecture. If you are having any query, you can ask me. Okay. Any question is there? Still some questions are there as far as your midterm exam or anything is there? Okay. If no queries are there, you may leave the lecture. If possible, I think that for DES algorithm, for DES also I take one test in next week for 10 minutes, so that which type of MCQs, what type of MCQs you can have for DES, you can have some idea. Getting this, so MCQ test for DES would also be there in next week. I'll tell you on Wednesday or Thursday when it would be there. So if you want, otherwise, just for your practice, otherwise the final exam is there of MCQ for your midterm exam. Theoretical exam, theoretical portion I'll ask you to write in your assignment from DES point of view once the chapter is over. Okay, fine. You may leave the meet.